Hello, my name is Cindy Vasquez. Today I'm going to talk about lecture 6.4 Boyle-Charles and Gay-Lussac, the gas law. So to keep in mind for the rest of the video, I am going to show you the equation that is pretty much based off of the equation I'm going to show you. So it's pretty much this. It's Pi Vi over Ti equals Pf Vf over Tf. So P is equal to pressure, V equals to the volume, and T equals to temperature. So please remember this equation because the equation I'm going to show you is pretty much based off of this. So the first thing I'm going to talk about is Boyle's law. So in Boyle's law, the main concept of Boyle's law, or the main idea, I guess, is if the volume increases, then the pressure decreases. If the volume decreases, then the pressure decreases. Yes, I know I did not mention temperature, but for Boyle's laws, the temperature is constant. That's why I didn't mention it. So this is the only law in which the properties are inversely related, meaning that they're opposites. So if one increases, the other one decreases, and vice versa. So, for example, let's say a regular size container, and if the container increases, then the molecules inside the container have more room for each other, so they're the speed of them hitting the walls is slower than before, so it's like chum, chum, chum. And if the volume of the container decreases and the molecules are scrunched up to each other, they're scrunched up, or they're less space within each other, so they're constantly hitting the wall. So choo, choo, choo. So pretty much the graph for this is this, and for Boyle's law, and the equation that I'm going to show you is this, which is Pi Vi equals to Pf Vs. I know I didn't mention temperature, but that's because the temperature in Boyle's law is constant, so we don't mind putting it in the equation. So the next one I'm going to show you is Charles' law. For Charles' law, as the number of molecules increases, so does the pressure, and vice versa. Meaning, if the number of molecules decreases, and so does the pressure. So example is as you heat up the molecules in the container, they start to move quickly because there's heat, so they start to move faster with against the container. They're just so it's making them hit the surface constantly. So from the constant hitting of the surface, the container increases, making it grow. So for Charles' law, this is the first law in which they have a direct relationship. So meaning if one increases, the other one decreases, and the equation is Pi over Ti equals Vf over Tf. I did not mention pressure because in Charles' law, pressure is constant, meaning that it stays the same no matter what. So the next one I'm going to talk about is Gay-Lussac's law. So for Gay-Lussac's law, when the temperature increases, so does the pressure, and when the temperature decreases, so does the pressure. So pretty much, to explain this theory, is that if gas molecules move quicker when they're heated up, creating more pressure by the constant movement. So pretty much as the molecules are heated up within a container or whatever, like a room or something, since the molecules are moving quicker than before, they are rapidly moving across the space that is given, or the space that is available to them, and they're constantly hitting the surface of the container, making the pressure increase. So since it is a direct relationship as Charles' laws, so it's the same graph, but keep in mind it's different properties. So, the equation for Gay-Lussac law is Pi over Ti equals Pf over Tf. So, I did not mention volume here to keep in mind, because in Gay-Lussac law, the volume is constant. So to bring back to the main equation I showed you in the beginning, as you notice, some of the equations I showed you before, there's always a letter that is kind of like shoved out the way or it's not there. That's because whatever letter I am not showing is meaning that's whatever it signifies is constant. So, for example, for for Boyle's law, for PIVI equals PFVF, that means that the temperature is constant. For this one, the pressure is constant. And for this one, Gay-Lussac, the volume is constant. So please keep that in mind.